Hello everyone, my name is Ria and in this video I'm going to explain the logic as well as the program for writing quicksort. So first of all, let me tell you that quicksort is one of the best techniques for sorting, and similarly merge sort and heap sort also are considered to be the best sorting techniques because all the three have time complexity big O of n log n, even for the worst case. So let us come straight to the point, that is, what is quicksort? So quicksort algorithm uses the idea of divide and conquer. It finds the element called pivot, which divides the array into two halves in such a way that elements in the left half are smaller than pivot and elements in the right half are greater than pivot. So we follow three steps recursively. Find the pivot. The first step, find the pivot that divides the array into two halves. Then quicksort the left half, and then quicksort the right half. So it must be a little confusing, but we'll just try to understand it using an example. So let us consider an array having 6 elements: 5, 2, 6, 1, 3 and 4. We have to arrange these elements in ascending order using quicksort algorithm. So we're writing it in this form. So this is our unsorted array, initially pointing to first element of the array left, and right initially pointing to the last element of the array. This is pivot. We are considering it as pivot, first element initially pointing to the first element, and we'll quicksort this array. So we have to remember two rules, that is, all the elements to the right of the pivot must be greater than pivot and all the elements to the left of the pivot must be less than pivot. So as the pivot is pointing at the left, pointing towards the left, so we start from right and we move towards left. So initially pivot is 5 and right is 4, and since pivot is not less than right, so we swap pivot and right, that is, these two elements are swapped, and now we move the pivot to the right, that is, the pivot is moved over here. Now the pivot is pointing at the right, and so we start from the left and we move towards right. Now pivot is equal to 5 and left is equal to 4. Pivot is greater than left? Yes, it is. So we move left one position towards right, that is, we move towards here. Now pivot is equal to 5, left is equal to 2. Now since pivot is greater than left, so we move one left position towards right. Now pivot is equal to 5 and left is equal to 6. Pivot is greater than left? No. So we swap pivot and left, that is, these two elements are swapped, and we move pivot to the left, that is, pivot is moved over here. Now the pivot is pointing at the left, so we will start from the right and we move towards left. Now pivot is 5, right is 6. Now it is again checking whether pivot is less than right. So it is yes. So we move right one position towards left. That is over here. Now pivot is 5, right is 3. Is pivot less than right? No. So we swap pivot and right. That is, these two elements are swapped. And we move the pivot to the right. Now the pivot is pointing at the right So we will start from left. We move towards right. Now pivot is 5, left is 3. Now pivot is greater than left? Yes, it is. So we move one left position towards right. Now pivot is 5, left is 1. Pivot is greater than left? It is. Yes. So we move left one position towards right. Now here we see that now both left and right are pointing at the same element of the array. This means 5 is the pivot and it is at the sorted position. At the sorted position. And elements left of pivot are smaller and elements right of pivot are greater. So pivot has divided the array into two sub-arrays. This is the left sub-array and this is the right sub-array. Now we will quick sort the left sub-array. This is the left, initially pointing to the first element of the sub-array, and this is the right, initially pointing to the last element of the sub-array. This is the pivot, initially pointing to the first element. As the pivot is pointing at left, so we will start from the right and we'll move towards left. Again we have to apply all those logic that we had applied before. Pivot is equal to 4, right is equal to 1. Now again pivot, we are checking whether pivot is less than right. Since it is not, so we swap the pivot and right. These two elements are swapped. Now we move the pivot to the right. Now the pivot is pointing at the right, so we will start from left and we move towards right. Pivot is 4 and left is 1. Since pivot is greater than left, yes, we move one left position towards right. Pivot is 4 and left is 2. Since pivot is greater than left, so we move one left position towards right. Pivot is 4, left is 3. Since pivot is greater than left, so we move one left position towards right. Now, since both left and right are pointing at the same element of the array, this means 4 is the pivot and it is at the sorted position. Elements left to the pivot are smaller. Pivot has divided the array into left sub-array and there is a wall at the right side of 4. Now this way we have to sort the other remaining elements which are unsorted. Now let's see how to write the code for this program. So first of all we'll be writing the header file, that is #include iostream, and we'll include the standard library file. Now first of all we'll see how we are writing the main function. So in the main function we are declaring an array of size 100 and then we are declaring some of the variables such as n, l, h and I, and we have to enter the compiler is asking the user to enter the number of elements it want to get the elements sorted, and then the user will be entering the elements. Then first of all we'll be displaying the initial array, and so that finally when we display the final array we'll be able to differentiate between the two arrays. And we are initializing h is equal to n minus 1 and l is equal to 0. Now we'll be passing h, l, h and a, that is l is 0, h is n minus 1 and a is the array elements. We'll be passing these elements to this function, that is quick, and after this function's work is over we'll be displaying the elements after sorting. So let us see what code has been written, what code is written for this quick function. So in the quick function we see there's the recursive call again. It receives the value l, h and a and index I. This condition is checked if l is less than h. If it is so, then index is equal to path of l, h and a, and then we are calling this function twice, that is recursive call is being done twice. After that, we see that there is a part function in which we have declared some of the variables, that is I, H, L, P and T. H we have initialized as high, L as low, and in P also we have initialized, we have kept the value which was at this position. Now we'll check the condition while low is less than high. If it is so, this loop will run until this condition becomes false. Now inside this while loop, we have another while loop which will be checking whether A of L is less than P. If it is so, then L will be incremented by 1. Now this L will be incremented by 1 unless this condition becomes false. Similarly, we have another while loop in which this condition is checked whether A of H is greater than P. Now H will be decremented until this condition becomes false. We have a if condition which will be swapping the element if L is less than H. Else we'll be swapping the elements if H is greater than L, and we'll be returning the value of H. Finally, now let us see how this program works. Here to enter the number of elements, suppose I'm entering 5, enter the elements 6, 7, 2, 3, 4. Now initially we had entered these elements, that is 6, 7, 2, 3, 4. Now it has displayed in a sorted manner, that is 2, 3, 4, 6 and 7. Now this is how my program works. Thank you.